Hello everyone, my name is Sabina and I'm from Sentinel Hub team, and I'm really happy to welcome you to our 5th live webinar. Today we will focus on data fusion and how to create multi-temporal scripts, and the presentation will be given by my colleague Monia Shebela, and as usual after her presentation the questions and answers section will follow. And now I would like to give the word to Monia to start with the presentation.
Hi everyone. We will start with data fusion and then we will continue with multi-temporal scripts. So first we will try to create a data fusion script, and in fact we will combine Sentinel-1 and Sentinel-2 to try to see through clouds. As you know, Sentinel-1 penetrates clouds, so this is quite a useful example. We will take a look at how you can create data fusion scripts and run them in your browser and request builder, so that you can then use the requests to send them in any of your application. And at the end of the first section, we are also going to take a look at a couple of data fusion scripts that other people did on our repository, just to give you a bit of an idea of what can be done. Before I continue with the agenda, the purpose of this webinar is to give you a tool so that you will be able to create these scripts yourself. So it might get a bit technical, as we have to explain some of the concepts so that you will be able to construct scripts, and also to explain all the necessary tools that you need. Also, in case you are not a programmer, I will explain everything to you. So in order to, in third part, take a look at multi-temporal scripts, we will have a part number 2, where we will take a look at mosaicking, what are different mosaicking types and what they can be used for, and how samples are selected, based on them what samples are. And then we will also take a look at what scenes are, what are JavaScript objects, and how you can access metadata. This will all be necessary so that we will then be able to actually really understand multi-temporal scripts. And we will take a look at how you can calculate the average NDVI for 3 different months. And then we will compare them by putting everything in one script and returning them all in 3 different color channels to see the changes. We will also take a look at how you can use our filtering script to filter the acquisitions taken into account. For example, we will check how you can only filter by 2 allowed dates, past 3 months, summer months. And at the end, we will also take a look at a couple of multi-temporal script examples that other people did, to give you a bit of inspiration to try it out yourself. Okay, so let's jump right to it. So we are starting with data fusion. I am here, I will go to the first page of our technical documentation. Here under data, you have data fusion. And here you can read about the documentation. You have some explanations on how to construct a body request, examples, and such. Here you can see quite some examples for you, such as, for example, how to pan sharpen Landsat 8 using Sentinel-2. Of course, I forgot to explain, in case some of you are not familiar with data fusion. Data fusion means that you combine different data collections, different satellites in one script. This is very useful as it takes advantage of both or even more than 2 different data collections at the same time in one single image. So if we jump to this pan sharpen Landsat 8 image with Sentinel-2, you can see the curl request here. If you remember from the Process API webinar, you can just grab this request and instantly run it in Request Builder or Postman and get an image. But we will try to create one ourselves. So I will now jump to an EO browser tab. I have the area near Sevastopol open over here. And as you can see, the Sentinel-2 L2A is being displayed. It is partly covered by clouds, and so we cannot see what is under those clouds. And we do know that Sentinel-1 actually can penetrate clouds. So if we combine them, we could, and this is what we're going to do, we will check if Sentinel-2 dataset has clouds present, and if it does, we're going to return Sentinel-1 imagery on the area of the clouds. And if there are no clouds present, we are going to return Sentinel-2, as this gives us a more natural image. So I will go down to custom script, and I will select use additional datasets. So in your browser, Sentinel-2 L2A is already selected as a primary dataset. So we are now adding an additional dataset that can be any collection that we want. You would select it over here. Of course, this needs to be collections that are supported by a Sentinel Hub Process API, because Data Fusion works with Process API and does not work with OGC. We are going to select Sentinel-1 GRD. And now the easiest way to do it, as I would say, is go to the examples, and then we would borrow the function setup, and we would pop it in. And then, of course, we would also need function evaluate pixel with samples. But so that we do not do all of this right now, I already have a script prepared that we will analyze in detail. But first, the most important thing that you have to understand to use these scripts is that each data collection has its own ID. And this ID can be absolutely anything you want. You could say pineapple and strawberry, it does not matter. It is not connected to any ID in, let's say, configuration utility or anything like that. It is just an ID that lets you, in case it would be easier for you to work with a different ID, but you can also just leave it as it is. So as you can see down here from the example, we took the Landsat 8 with the ID of Landsat 8 and the Sentinel-2 L2A. And now over here, you can see data source alias. This is this ID. We can choose anything we want here. We can just select S2 for example, Sentinel-2. And then the only thing we need to be careful is that in the eval script, this ID is inserted. Over here, we forgot to click the plus button to actually add the Sentinel-1. Also, of course, we would like to enable the auto rectification so that we do not get a slanted terrain. And then again, we can choose any ID that we like, let's say S1, but we have to be careful to also insert it into our eval script. And of course, we would now also select different bands over here that actually match Sentinel-1 and not these Landsat 8 ones. And then down here in the evaluate pixel, you would also need to operate with these IDs. Let me quickly jump back to the examples. And let's take a look at how the request looks like. You can see that in the request body, you have the collection type, which is in this case Landsat 8, and then you have the ID. So this is where you would write this ID that can be anything you want. And as soon as you call this ID in your eval script, the system instantly knows that you are referring to Landsat 8 because this is the ID that you connected in your request body. The same is done down here for Sentinel-2. You could, of course, add other data sets of the same type or different type. For example, you could add another Sentinel-2 L1C if you wanted. Give it a name, an ID or not, or just leave it like that. Okay. I am now jumping to the tab where I have the script already written. And now let's take a look at how it is structured. So here in the function setup, you can see that we have the ID setup. So the S2L2A is the ID that is inserted here, and it represents the Sentinel-2 collection. It could be named anything. And same for Sentinel-1. Then we have the bands. And for Sentinel-2 L2A, next to the true color bands, we also added the cloud mask. So let's quickly jump to documentation. Let's go to Sentinel-2 L2A and check the available bands. You can see here you have the cloud mask. If you go to units down there, you can see that cloud mask has three possible values, 0, 1, or 255. And if it is 1, then clouds are present. And if it is 0, then clouds are not present. So you can use this to check whether clouds are present or not. Okay, so this is why we inserted this band. And then in the evaluate pixel, what we did was we created two new variables, which we named whatever we like, in this case S1 and S2. And then we connect them to samples dot and the ID. We always operate with the ID in the eval script. And then this 0 will be explained later. So yeah, the samples and these zeros will be explained when we get to the second section. We will just jump over this for now. Just know that this is how we actually call data into our script. We do this so that we don't have to constantly write samples.s1grd of 0, but we can then just write s1. And then over here we have a simple if statement that checks whether cloud masks is 1, and if it is 1, that means that clouds are present. And in this case, we return a nice Sentinel-1 RGB composite. And if clouds are not present, if else is true, then we return the true color Sentinel-2. This is all there is, and over here you can see that the clouds that we saw before are now actually, here you can see Sentinel-1 coming through, and we can see a lot more information on what is actually going on the ground. For example, if we jump to another date over here, the 10th, you will see a lot more areas covered by Sentinel-1 because a lot of more was covered by clouds. Another important thing that I have to mention, it is in your browser and also in Request Builder, it is important that all the data sets that are over here match exactly what is down here. So if you had, for example, up here the Sentinel-3 and then didn't use it, you would get an error. It has to match exactly. Such as in the request, what you have under data over here has to match what you actually use in the eval script. Now let's jump to Request Builder. Under the Process tab, you would go to Data Fusion. And just the same as it was in your browser, you get a data source that you can select whichever you want. For example, Sentinel-2L2A and Sentinel-1GRD. And then we can use any ID, let's say ID1 and ID2. And then all we need to do is use these IDs to refer to our data collection in the eval script. We could now grab this eval script that we have created, put it in here, and then just make sure that the IDs match. For example, like this and like this. And then we could also select the correct time range over here if we wanted it to be on the same date, for example. And then when we click the send request, this would send the data fusion request. It is not complicated. Data fusion is actually pretty straightforward. Now, if we jump to the collections of custom script, you can see these links will all be posted in the description, so don't worry about writing them down. Down here on the bottom, you see data fusion. If I click that, you see several data fusion scripts. For example, if I open up the digital elevation model contour lines, which overlays contour lines over Landsat 8, I could open it in your browser, or I could just grab the eval script, go to Request Builder, pop the eval script in, and then again, I need to be careful to match the IDs. So it is much easier for me to grab the IDs from the actual script and insert them into the request body than to do it otherwise, to choose something over here and then change it over there, because then I have to be really careful not to miss any mention of that ID. So we have Landsat 8. Let's select Landsat 8 and give it the ID that is used in the script. Let's do the same for digital elevation model. And now if we run this, here in the request preview, you can instantly see that it is updated. You can see the ID and the data collection that was selected. If we click send request now, if we did everything correctly, we should get an image of Landsat 8 covered by some contour lines. Okay, let's just quickly take a look at a couple of examples. So this first example, all of them are available on our custom script repository, so you can check them out here. They have the descriptions and such. Over here, what was done was that actually two different Sentinel-1 collections were added, each with its own time range. So this could technically be called also a multi-temporal data fusion script and a Landsat 2. And then what was done was that the fire progression, the burnt area, was displayed on each different date, and then both of them were displayed in different colors so that you can see the progression of how the ground was burnt and how the fire progressed through different dates. Then we have the ship detection script, which uses Sentinel-2 and Sentinel-1. And what it does, it uses some thresholds, such as, for example, checking for water for Sentinel-2 and using some 0.3 or larger for the VV polarization to map the water and the ships. And then where there are ships, the Sentinel-1 is returned, and everywhere else, Sentinel-2 is returned. And this is supposed to map the ships. In a time lapse, we could check how they all move. And it is all done using some conditional statements that you are already familiar with from the first webinar. Then here we have combination of Sentinel-5 and Sentinel-3 AllSheet. So Sentinel-5, where it does not have data, in this case we are using a cloud top pressure. Where there is no data, there is simply black or transparent, so that you do not see what is beneath it. And so in this case, where there is no data for Sentinel-5, we checked for this, we return to the Sentinel-3. And this way you can see the sea under the cloud top pressure imagery, which looks a lot nicer. Over here we have a digital elevation model, one that we already checked. It calculates the contour lines and then overlays them over Landsat 8. Okay, let's jump back to our agenda. We have checked how data fusion works now. And now in the second part, it is going to get a little bit more technical, but it is well worth it, because if you understand what I'm going to be talking about, you will then be able to actually write new and original multi-temporal scripts, which is quite awesome. So now in the second part, we are going to first take a look at what are samples and what are mosaicking types. Back to the web. So over here, I have the simplest multi-temporal script that I could think of. And immediately, as you can see, it is using Mosaicking ORBIT. And it is using these samples that we just glossed over until now, but we're going to actually take a look at what this means. Until we understand it, we can't really work with this. So we are going to now take a look at mosaicking. In our documentation, if you go under evalscript version 3, and then over here on the right, you see mosaicking. Here you can find the documentation for the different mosaicking types, simple, orbit, and tile, that I am going to be explaining to you now using some graphics that we prepare to make it clearer and more visual. If we jump to EO browser, I'm sure that you are all familiar with this, and you click search, you are going to see some tiles displayed. And if you see, some of them, in some areas, there are multiple tiles present, especially here in the corners, you can have 4 or even more. So if we had a little bounding box down here, it would be covered by several tiles. And each of them has its own acquisition time, which is displayed over here. So 2 tiles can have 2 same acquisition days, but they are going to date in the exact acquisition time. As you can see, there are a couple of, they are very close together, but not exactly the same. And if 2 tiles are not very close together in acquisition, the pixel values of, let's say, Sentinel-2 reflectance can actually differ. So if we, for example, click here, we can see that on this area at the moment, 2 of them are overlapping. Now I'm going to jump to the graphics that we have prepared. Samples. So if you imagine this grid to be your bounding box, and each of those little squares is the pixel that has, for Sentinel-2, for example, a resolution of 20 times 20 meters. And let's focus on this little pixel over here. So for each tile that is covering your pixel or your bounding box, you're going to get a different value for that pixel. And if we have 3 different tiles overlapping your bounding box, this is going to translate to 3 different samples. So the sample basically means the value that was taken from a specific tile or a specific scene. So in this case, sample 1 was taken, the value was taken from tile 1. It was acquired on 23rd November at 2 p.m. So this was the latest acquisition. Then it was the second latest acquisition from where there was tile 2 acquired on the same day, but a couple of hours earlier. And this would then become sample 2. And then the third tile that was acquired, the least recent, in this case, the 5th of March at 9 a.m. This would then become the sample 3. And this is the oldest one. And now how they're going to be selected depends on which mosaicking you choose. Let me jump to Mosaicking SIMPLE. Mosaicking SIMPLE means that only one acquisition at the same time is going to be selected. This means that you're going to get only one sample per pixel. If we take a look at the black pixel over here, you can see that it is being covered by only one tile, only by pink tile. It is not covered by the blue one or the yellow one at all. So because only one sample is being selected, in this case, the only available one is going to be selected and you are going to get just one sample. And if you would be using the advanced script with simple mosaicking and you would be using Sentinel 2, this would look like you would be calling it as sample.band4 because it's only one. If we take a look at the green pixel over here, now here we have several tiles on different acquisition dates, and now here the system needs to decide which one to select. And this now depends which we choose. So Mosaicking SIMPLE has 3 different options. We can select that the most recent one is going to be selected. In this case, of course, only one, the most recent one will going to be selected. This is the one that was acquired least time ago on the November 23rd at 2 p.m. Then if you selected least recent in your request, the least recent one, in this case, tile 3 would get selected and not tile 1, because only one would get selected. And there is also another option, a least cloud coverage or least CC. But that would mean that the one will be selected which has the least clouds. But be careful because this is only available for certain data sets. We will now quickly jump back to our internet and go to data. If we go to, for example, to Lancet and scroll a bit down, you can here check which mosaicking simple types are available. So for Lancet 8, all 3 are available, but for example, for PlanetScope, least cloud coverage is not available. If nothing is written, that means that most recent one will be selected. So be careful about that. Okay, so this is about Mosaicking SIMPLE. So just to repeat, only one sample is going to be selected based on your criteria. And then for multi-temporal scripts, what we are working with is several acquisitions per pixel. So this means that we will not get only one sample per pixel, but we will get several if there are several available. This is the point of multi-temporal, so that the multi-temporal means using multiple acquisitions at the same time. And here we have 2 options. We have option Mosaicking TILE and Mosaicking ORBIT. This means that we are working with multi-temporal scripts. We have to choose either Mosaicking TILE or Mosaicking ORBIT. Now let's take a look at how Mosaicking TILE works. First, let's check the green one, the green pixel. So basically, for Mosaicking TILE, all the available samples are going to be selected, all of them. So for the green pixel, it is covered by 3 different tiles and 3 different acquisitions: the pink one, the blue one, and the yellow one, or as they are called here, tile 1, tile 2, and tile 3. And actually, all of them will be selected, regardless of the acquisition date. Each of them becomes its own sample. And which one becomes becomes sample 0 or the first one, sample 1 or the second one, or sample 3 or the samples 2 or the third one, depends on the recency. The latest one is going to be samples 0. So if you will write in your script samples 0, you will get the first available value of the first available tile that covers your pixel, or the first available sample. Now, this black pixel is covered only by one of those. And now what happens with this one? Now the rule with Mosaicking TILE and ORBIT is that each pixel needs to have the same amount of samples. It cannot be that black pixel would have only one sample because it is covered by only one tile, and the green one would have three because it's covered by three. Both of them need to have three. That is because as soon as the green one gets three, the black one also gets three. If the green one had a 10, then the black one would also get 10. This means that you could go samples 0, samples 1, up to 9. But what happens is that because the black tile, even though it gets 3 samples, has essentially 2 samples empty, so the one from tile 2 and tile 3 do not overlap the black pixel. This means that the pixel will get assigned the value 0 or a data mask value 0. So in case you would be looking at a reflectance image, for example, of Sentinel 2, this pixel would appear if you would request samples of 1. You would be requesting the tile where there is no data. It would be black and it would have a value of 0 because black corresponds to 0, as you saw in the first webinar. But also, you can check for this by using data mask because data mask maps no data values, and you could then filter for this. The same is, of course, if you would request samples of 2, this pixel would have a value of 0 and it would appear black. But if you request samples of 0 from the tile 1 where there is actually data, because the tile actually covers the pixel, then you would get any of the reflectance value that actually is there, be it from 0 to 1. If you are using sample float 32 and or reflectance units. Okay, so the last one we have to take a look is Mosaicking ORBIT, which is also for multi-temporal scripts, but it works a little bit different. So the orbit, if we jump back to our EO browser, you can see orbits as these large swaths that have several tiles in them. And if it would be loaded, it would go all up and all down. And here you can see the other one. So this is what the orbit is. And now in this case, we have 2 orbits. And each of them was acquired on a different day. In most cases, your pixels are going to be covered only by 1 orbit per day. And in this case, both of them are going to be selected. All of them are selected, same as with tile, but the whole orbit is actually selected. And the most recent one, same as before, is going to be samples 0, is going to be the first one in the array. And the orbit 2, which is the next most recent one, is going to then be samples 1. But what happens if one of the pixels is not covered by one of the orbits? Again, as before, as soon as this black pixel gets 2 samples, the green one also gets 2 samples. But if we requested samples of 1, which corresponds to the orange orbit number 2, where it does not cover the pixel, we would get the pixel value of 0 or a data mask value of 0, the same as with tile. Now, it could happen that in some areas, such as near the poles, there would be more than 1 orbit per day. In this case, the most recent one would get selected. 1 per day, most recent one. But this is quite a rare occasion. Okay, let's jump back to our simple script. So as you can see, we have Mosaicking ORBIT set up. So hopefully you now understand what this means. It means that more than 1 acquisition can be selected. And over here, you now see we have 3 variables set, date 1, date 2, and date 3. And here we call samples of 0.band4. This means that we are calling band 4, and actually we want the first available acquisition. So this is going to be the first available one, this is going to be the second one, this is going to be the third one. And what I did here is I returned each of them in its own color channels. And like this, you can see the changes through time. So you can see the red color is date 1, the second is date 2, and the third, the blue, is date 3. If you see, for example, some pink colors, that means that there was high reflectance on the first and the third date. This example is not particularly useful, but it works just to demonstrate what it means. So what would happen if I only returned one of those? If I returned only one band and I said only return date 1, I would then get only data from the first available tile, which is the samples of 0. Now, the next important thing we need to understand are objects. So we somehow are going to need to access metadata so that we will be able to filter scenes using our filtering function later. And for this, the JavaScript has a thing that is called an object, and it includes basically key value pairs. The key can be anything, and then you have the value over here. I have set up here so that you can see it is fruit, the value is pineapple, then we have the key NDVI, and the value is the calculation of the NDVI. The wetness index and the calculation is the wetness index, and the ban and the value is band 4. And now this is very useful because in this way you can store different types of information in one object. And the important thing that you need to understand, it's very simple, is just how to access it. You access it by saying object, and then using dot, and then calling any of these key names, and you will get returned the value, which is this thing on the right. So if we say NDVI now, and click refresh, we will get NDVI returned, because we requested this, and we got the value back. If we say the wetness index and click refresh, we will get it. Now these objects could be called absolutely anything, any name, but then we would have to also call it by the same name. And let's just select band. We have to request the key, and then we get the value back, like that. Now that you understand this, the next thing I will explain is what are scenes. If we go to our EvalScript version 3 documentation and go to evaluate pixel function, you will see that the evaluate pixel function has sample and it has scene, and then also other things that we will not deal with right now. And the sample we already covered. It is an object containing band values, and then the scene is the scenes are essentially just metadata for samples. So for sample of 0, you would get a scene of 0, and this scene has some metadata attached. Over here, I have run the request that returns the metadata of the scene object so that you can see what is collected in it. So for each of the samples, we get the metadata, which is called a scene. And you can see they are listed down here. There are as many as were available in the time range that I requested. And you see that this is essentially an object with key value pairs that we looked at before. You have date, which is a key name, and then you have the value of it. And then you also have the IDX, and then you have the value of it. The IDX is just the index number of this specific scene. And then again, this is another one. You have a date and you have the IDX. Okay, so if you wanted now to access, for example, this date, what you would do, as the same way as we did before with our object example, you would go scene.date, and then this would be returned. And if you wanted to get the index number, you would get scene.idx, because the object is called scene. So now I think we can jump to actually making the multi-temporal scripts that we understand all of this theory. Over here, I have borrowed the script from Harel Dan from the custom script repository with the average calculation of NDVI. And I have modified it just a little bit. Here I have it calculated for only 1 month. And what is happening first, we calculate the function NDVI, which is just setting up a variable which calculates the normalized difference index and returns it. And then in the evaluate pixel, we have samples and we have scenes. We set up the variable AVG, which is supposed to be average. It means average, and then the count. So this is just a placeholder so that we will be able to assign values to this later. And then over here, we have a simple, just a JavaScript for loop, which is going to take all the scenes that are available, starting with the first one, and going as far as the array is long, so until the last one. And each time it is going to go to another one. So basically this just says for every scene, run this code that is written in here actually. Another important thing, if you are not familiar with JavaScript, I have collected here a couple of useful JavaScript methods that keep popping up. It is useful for you to know which of the things that you are seeing is a JavaScript method that you can look up and which of them is a specific thing of our Sentinel Hub. So we have here, for example, some time-related methods and some other methods. For example, if you say new date, it is going to create a new date object, for example, like this. Then you have also get time, which is going to return the number of milliseconds, and also get month, which returns a number from 0 to 11 based on which month it is. Also get full year and so on. And then we have other useful methods. For example, here we can see dot length, which will get the number of elements in an array. So if we say dot length, it is going to tell you how many things are in that array. We have a dot filter, which we're also going to see later. Stringify, which just converts an object into a string. Includes, which checks if something is present. Like, for example, if a character is present in a specified string. We have split, which splits a string into an array of substrings. Sort, which sorts something ascending or descending. Index of, which checks in which order is it the first one of the array, the second one, the third one, and so on. So here is a useful website where you can check out all these methods and also all the other ones. These are just the most common ones that I have found. Yeah, so over here you can see a dot length used. It checks for the length of the array. Okay, so in this for loop, the first thing that we check is whether there is no data present. We check for data mask, which we also inserted up here. And if it is not equal to 0, that means that there is data present. Because if data mask is 0, then there is no data. But if it is 1, then there is data present. And if in fact there is data present, so we are not, the scene that we are looking at is not one of those which does not overlap our pixels, but it is one of those that does and actually gives us useful data. Then we just set another variable which calls the NDVI, the NDVI function, but instead of saying samples of 0 or of 1 or whatever, it says of I, which means for each one. So it will just grab the NDVI of each scene that it loops through, and then it will set this AVG variable to also include the current NDVI value, and then it will increase the count to a higher level. So at the end, we are going to get this count will be a number that is equal to the number of scenes. Then at the end, all we need to do is calculate the average by just dividing this AVG, which holds the NDVI, with our count, which is how many scenes they are, and we get the average NDVI. And now, for how long we get this average NDVI, this is going to take all the scenes in the from to date that we specify in our request. So over here in EO browser, I have it set to 1 month. If I set it to 1 year, I would get all the scenes in 1 year, and I would get the average of 1 year. So this is already really useful. So how you would do that in a request builder? You would just go to the request builder. You would pop in the script. Of course, check that you have the correct data set, and then you would change the time range to fit your needs. Over here, I have absolutely the same, the average NDVI, but for another month. If we check the time span, this one is from June to July. The previous one was from July to August, and this one is from May to June. And if we click between them, you see that they are different. The average NDVI was different for each month. So what we can do now is, I have the script already over here. We just do this for each of the month. And over here, what is happening over here, we're accessing metadata here. So this is why we needed to understand everything before. We have to figure out which is the latest month in order to use this script. And in this case, we just set the variable end month, and we go scenes of 0 and then dot date, which we checked before in how the metadata for scenes looks like. And this is going to give us the date string. If I just repeat it again, if we go scene.date, it is going to give us this, the actual date. And then we use the JavaScript method getMonth, which is going to extract the month from that. It is going to give us a number from 0 to 11, so that it's 12 of them. Yeah. And then we have the for loop again. And actually, here we then have if statements for each month. So first, we check if the actual month of the scene that we're looking at equals the end month that we specified over here. And as we have the 0 over here, scene.0, this gets the month of the latest one. And then we just check if the month of the current scene that are just, you know, it loops through all of them, equals that. And if it does, then this is the current month. Then we do everything the same as before, just that we need more variables so that we can calculate this NDVI and the count for each of the months. And then over here, if we just subtract -1 here, we are going to get the previous month. And then we can just use else for all the other months. But for this to work, we have to set the time range to exactly 3 months. Yeah, actually, this should then, it would be best if it would be March 7th to June 7th. And at the end, we calculate the averages for all of them and then return each of them in its all color channel. And this way, we can see the NDVI changes through time, through 3 months. We see that the red ones had high reflectance NDVI values on the first month and 0 on the, or very little on the other 2. The blue one had the high NDVI values on the third month and 0 or little on the first 2, and so on. And where the colors mix, for example, purple, NDVI was high in the first and in the third month. So in the single image, we get a lot of information over here. We could, of course, do this for more than 3 months if we wanted to. Now we have actually filtered the scenes taken into account by just manipulating the time range in the request itself. Such as in Request Builder, we did it over here, which changed over here, but we can do much more than that. We can use a filtering function called preProcessScenes function. It is optional, but it allows for a much higher level of filtering. You can do much more. You can, for example, say, I want scenes that are from June and from April and nothing else. You can't do this by just changing the time range. And with everything that we have learned, it shouldn't be too difficult to understand this function, even though it is not completely simple. So bear with me. So this function has certain parameters, and it works differently whether the mosaicking is orbit or whether it is tile. Let's check how it looks like down here. So the function preProcessScenes is set up, and it has collections over here. So the collections means it could be, this function can be also used for data fusion. And so the collections here could be, for example, Sentinel-2, depending on what you have chosen in your request. And then all of this is what the function does. Here we are going to constantly be using the objects and accessing metadata. We go collections, we go .scenes, we go .orbits. And now let's check what all this means first. If mosaicking is orbit, this collection of, object of the function contains from, property, to property, and scenes.orbits. So from is the from date representing the start of the search interval, and to is representing the end of the search interval. It is equal to what you set in the request, as we did before. And then it also has scenes.orbits. And this is now an array of objects where each of them represents one scene that you are working with. So for example, samples 0, samples 1, samples 2, or better yet, scenes 0, scenes 1, scenes 2. And these are called objects because they as well have some metadata attached. They have date from and date to. So for mosaicking, what is happening is that all the tiles that were acquired on the same day are mosaicked into this scene. So these are kind of absolute from and to values that you can access. In Mosaicking TILE, it is a bit easier. The collections object also contains scenes.tiles, which are your scenes. And these tiles have then some properties, which are date, the ID, the cloud coverage, and so on. Let's quickly take a look at how this looks like. I have it returned over here. And if you see, this is for the Mosaicking tile. The scenes look like this. They have a key of date and the value of date, as we saw before. They also have the ID. And then if we filter the scenes, we see cloud coverage, as you can see over here. So these scenes are actually now collections.scenes.tiles. And then if we went .cloud coverage, we would get this value. It is just objects collecting data by going deeper and deeper into it. Okay, so let's go back to the example where everything will hopefully clarify very quickly. So when we say collections.scene.orbits, we are accessing the scenes for when we are using Mosaicking Orbit. And then we set it to the same thing, but we filter. What filter does is checks for a condition that is specified here. And if this condition is true, the scene is going to be selected, otherwise not. This is how the filtering works. And then over here, we have another function, which is basically, which is a condition of this filter. And over here, we have scene. So this could be anything, but it is actually over here means orbit. In this example, the only thing we're doing is, does the date of the sample that we are checking, is it earlier than any date, the date that we set here? If it is earlier, then select it, otherwise discard it. And it is done by using a JavaScript method date that we looked before. New date, we set a new date, and then we just call the metadata. We say scene.datefrom. Why scene? Because scene is here in the parentheses, and we are already in collections.scenes.orbits. So what this essentially means is collections.scenes.orbits.datefrom. Why? Because over here, it goes collections.scenes.orbits.datefrom. This is how you access it. It is just dots and following the structure. And then it will return to you the actual value of this parameter. Now let's take a look at a couple of other examples. Over here we have that we set, for example, 2 allowed dates. Only these 2 dates are allowed and none of other ones, which are the variable is set here and the array of any dates that we choose. In this case, these are before and after the Knizna fires. And again, the structure is the same all over here. Here it is the filtering condition. And the filtering condition is we set the variable, and this variable is going to go to collections.scene.orbits.datefrom, and it is going to split on the t, which if we check the date, here is the t, and if we split here, we get just a date the same as we wrote it in this format. And this way we can then compare. We can say, okay, now return those scenes where the date actually is included in our allowed dates. So if the date of the scene that you are checking matches what we have written here, then select it. If your mosaicking is tile, the only difference is that instead of collections.orbits, you have tiles. And instead of saying tile.datefrom, you have date. Why is that? Well, because for tile, it goes collections.scenes.tiles.date and not datefrom. We can also filter by time interval. We could say, check the date from this scene. And if it is smaller than this date I set up, select it. Or if it is larger than this date I set up, select it, for example. And then if you set in your request, for example, if you set from January 1st to June 13th, this would then actually select all of January and all of June for you, but nothing else. And if you turned this around, you would then get the between dates. But this you can already do by just setting a time range in your request. Let's jump to Request Builder. Over here, I also have the summer months. that I promised for you in the agenda. And let's just take a look at it. So we are using Mosaicking TILE. We could also be using Orbit. And in the evaluate pixel, we are going to return a true color of Sentinel-2. So what we are now doing, we are going to filter to get only the summer months. The first thing that we do is we arrange the scenes in ascending order by using the sort JavaScript method that you can look up. And then over here, we set our filtering condition. And we say, well, if we set the variable where we get the date of the current scene, remember that for tile, it goes collections.scenes.tiles.date. And then we say, well, if this matches the get month of 5, what this does is it gets into collections.scene.tiles.date, .getMonth, and .getMonth is going to extract from the date the actual date, as we said, from number from 0 to 11. So if it is 5, this means that it is June. Then we say the or, and we say the same thing, or if it is it matches the July, or if it matches the August. Then select it. This is how it selects the summer months. So in our custom script repository, you have the multi-temporal scripts. There are quite a lot of them. They are scattered. They do not have a special category yet, like for the data fusion. And now if we just very quickly take a look at a couple of examples. So here, the flooding is being displayed by filtering, by selecting only 2 allowed dates. The one is where we know there is flood, and one is where we know there was no flood. And then you can divide by them and display the difference in the red channel, displaying the flood. Over here, similar thing was done, checking the burned area on one day and on another, and on third, where we know it was burning, and showing some progression. Here we have the snow. What this script does is it takes the version, I forgot to explain this one. So this version is actually, it's nothing complicated. It just checks if the current time, get time converts your date to milliseconds, matches these milliseconds over here. So these are the milliseconds that correspond to 3 months. You can just grab this function, pop it in, and if you say 1 here, it is going to be 1 month. If you say 3, it is going to be 3 months. So it just checks whether the snow was consistently present for the last month, as you can see over here. And then we have, for example, the radar vegetation index, which does the same as we did with the average NDVI, just that the index is calculated for the Sentinel-1. And then you can see the changes during the 3 months. Let me go back to the agenda. Yeah, so we have covered everything. Thank you all for joining this webinar. I am really looking forward to seeing all the awesome scripts that you are going to create. Thank you.
Thank you, Munia, for a really thorough presentation. As mentioned at the beginning, we will continue with the questions and answers section. Let's first check those written in the chat during the presentation. The first 2 questions from the group chat are referring to data fusion part at the beginning of the presentation. A question, what kind of image fusion is used here? I will ask my colleague Anya to jump in to help me with answers.
Hi, everyone. Maybe one thing to explain regarding the data fusion here is that by data fusion, we are referring to technical capability of our API to actually request more data collections in one request. How exactly you combine this data is then up to each user. You just have to write the eval script so that you come to the results that you want. So what Monia showed, for example, was replacing some of the cloudy pixels in Sentinel-2 image with data from Sentinel-1, for example. So that's just one option. But it's up to user to actually decide how the data will be processed.
So I guess your answer refers also to the second question when Sindhu was asking how it is possible to fuse SAR and MSI imagery, right?
Oh, yeah, I think so.
Hamado is asking which method of mosaicking would you recommend for use?
I would say most of the users would be looking for Mosaicking ORBIT, so that they would end up with one data sample per day. Finally, it depends on what you want to do, but I would suggest trying out Mosaicking ORBIT first if you have not tried working with multi-temporal scripts before.
The next one from the same participant. Can we return many parameters at the same time with the object?
Not sure that I completely understand the question. One way to return things from eval script is to just write values to an image and then return that, or another way is to write data into user data file, which is a JSON file, and that also can be returned from the Sentinel Hub process API. And in this file, you can write basically anything. So for example, if you use some value to, let's say, normalize your data in the eval script, you could then write this parameter down in your user data file.
So Hamado, I actually unmuted you. You can unmute yourself. You should be able to do that now if you want to elaborate, if you have additional questions.
Can you hear me?
Yes, we can hear you.
Okay, thank you very much. What I was trying to ask, when you write on the script, let's object after you specify the parameters like NDVI, normalized water index, and the band. So when you set return object just dot NDVI, you are just choosing one parameter that you want to return. The idea is just, is it possible to return many parameters, let's say NDVI and normalize different water index of other parameters at the same time?
Okay, I see. I understand the question now. Yes, that the answer is yes. So once you have your data in the evaluate pixel function, you can calculate whatever you want from it. So NDVI is an example. You can return raw bands. You can multiply bands by any value, and then you would return this as separate bands in the output of evaluate pixel function.
All right, thank you very much.
Welcome.
So after this part, we actually went through the Herald Dance script explanation. The next question came from Gabriel. Is there some way to extract and record the pixel values? He means the numeric value of the NDVI, for example, in a specific area of interest.
So if you're looking for NDVI value per pixel, probably the best option is to simply return an image from a Sentinel Hub API. Now, Monia was mostly using EO browser, so your area of interest was what you saw. But if you use an API, then you could send your area of interest as bounding box or geometry. And then you would just return the NDVI for each pixel that falls in your area of interest.
And you can also use statistical API to check for the actual value changes if you want.
Inas was wondering if there are certificates for participants of our webinars. Well, we don't provide any certificates at the moment, but we will think about it for the future events. Thank you. Christina was asking what type of account is necessary for assessing all these functionalities. Are there any subsidies for research? So at the moment on the screen, you can also see the link to the Network of Resources program, which offers ESA-sponsored accounts. And it's available for conducting research for search purposes and for pre-commercial exploitation. So I would just recommend you to follow this link. Then the next question, it's about data fusion. When there was cloud, from where did you get the Sentinel-1 to RGB relationship? Munia, would you like to attend this answer?
Yeah, let me jump back. So I said if the clouds are present, then return the RGB of different Sentinel-1 polarizations, which are set up here. And this is just an RGB output. Here are some multiplications and such for a nicer visualization. And then if there are no clouds, then I return the RGB output of Sentinel-2 bands, which are known to provide a true color image. Does that answer your question? Another thing I would like to mention, so there is a related webinar that was before this one, the custom script webinar that went into very basics of scripting, how to make RGB composites, indices, visualization, stuff like that. So I also encourage you to take a look at that webinar.
Okay, thanks. So actually, my question was about where did you get those this relationship? How did you get that R is approximately 3 times VV and so on? If you have a source or something like that for that.
Oh yeah, right. I do actually. I think I borrowed the script from the Sentinel-2 with cloudy parts replaced by Sentinel-1 by Pierre. I think it is this one.
Then we also got another question, what level of technical support is provided to enterprise subscribers if there is any training, additional training available or coding support? So to all enterprise subscribers, we actually offer 1 hour support per month via email. You get actually the priority email support during your usage. And we are always available on our forum. Then another question is also about calculation. All the calculations are done on DN values and calibrated values. Is that true?
So when you request data with Sentinel Hub API, you can specify in which units you want to have the data. So for Sentinel-2, for example, you can either request digital numbers or reflectance data. The default is reflectance, so this is what is used in EO browser. If you use, for example, simple script, you would get values as reflectance.
Mehmet is also asking, can you add a pixel inspector like GE?
Yeah, that's a good point. I myself was I'm quite used to using feature info tool in QGIS, for example. There is a way to drop a point in your browser and then get the time series with values, so that can help to some point. But yeah, I would agree that having something similar to feature info would be beneficial.
And in the chat, the last question, does the Sentinel Hub JavaScript platform support machine learning algorithms?
It does actually support our EOLearn, and on the custom script repository, we have a couple of EOLearn scripts. For example, here in the Sentinel-2, we have a deep NDVI vegetation algorithm, which uses the EOLearn framework.
Okay, so we actually came to the end of the questions set in the chat, in the group chat. If you have any additional questions, you might raise your hand and I can unmute you so you can ask. Otherwise, I would really like to thank you for being with us today. As mentioned at the beginning, the recording will be sent to you in the coming days as soon as it's available. And all the relevant links from today's webinar will be stated in the recording's description. If you don't have Sentinel Hub account yet, I would also encourage you to create a 30-day trial account. And you can also purchase one of the subscription packages which fit your needs best. Otherwise, don't miss this Network of Resources program, which was mentioned before, which is actually perfect for research or if you are in a pre-commercial exploitation phase. And it provides ESA-sponsored accounts and free access to high resolution commercial data as well, nicely described in our previous webinar. And I would also like to invite you to stay updated, follow us on social media. If you have any other questions, you can also always attend our forum. And thank you very much for being with us today.